All right, we need to take a little aside to prove a particular vector property here that, in general, vector A dot cross product of vectors B and C is the same as A cross B dotted with C, okay? And in this proof, I'm going to break out, vectors A, B, and C into these components with the subscripts X, Y, and Z. So I'll start with this left side here, A dot B cross C, and we'll start rewriting this in terms of the components that we wrote up here. So the A, A sub X, A sub Y, A sub Z, okay, is going to be dotted with the cross product. Now the cross product being all this lovely stuff. You can look up the formula if you need to, but it's, BY minus BZ CY, comma, BZ CX, oops, that should be the X, minus BX CZ, comma, BX CY minus BY CZ. Made that all fit. Great. So now we're going to do this lovely dot product here. So we have AX, and I'll just multiply it by that first term, BYCZ minus BZCY. Okay, plus the next term, AY times BZCX minus BXCZ. Getting a little hard to read my writing here, plus AZ times BXCY minus BYCZ. All right. Now this stuff can actually all be written as a determinant here. So let me rewrite this as a determinant as AX. Maybe you can see this here, right? The AX is being multiplied by BYCZ minus BZCY. Do you see how that works in a 3 by 3 determinant? Oops, that's a little sloppy here. Gotta rewrite that. That was the BZ, and this is CY, CZ. So just that part of the determinant gets that first term here. Likewise with the second one, the AY goes here. It's AY times BZ times CX minus AY times BX times CZ, and then likewise the last one. Okay. So it turns out that this A dot B cross C is this 3 by 3 determinant, which is actually kind of a neat setup. But you can also dissect this determinant another way. We could dissect it, or if we start multiplying it out here, we can say, look, it's going to be this CX term times, AY times BZ times CX minus AZ times BY times CX, in that sort of a manner. And then approaching it that way, sort of factoring out a little bit, we get AY BZ minus AZBY, sounds a little crazy, and all that times the CX. And likewise, we can do it for the other terms, factor out a CY for its terms, and we get AZ BX minus AX BZ times CY, and likewise the last set, AX BY minus AY BX times CZ. Well, that can be written then, all that stuff factored out, as an, AZBY minus AYBZ. Yeah, you can work the rest of these out. Right? The rest of those dotted with CX, CY, CZ. Sorry, getting a little sloppy. But that's just saying, oh, this first thing ends up just being vector A cross vector B, and all that dotted with vector C, which is what we wanted.